Hello, my awesome students. What do you think we are going to study today? Let's go and see. Today, we are going to study solving equations in one unknown. Oh, it's gonna be fun. Let's begin and see. But first, I have a question to all of you. What is the value of 4? And what is the value of x? Pretty sure that all of you will say that 4 is equals to 4. And this is real. All of us know that 4, its value is 4. It will never change. But what about x? I'm quite sure that each one of you is going to jump into a different value for x. Someone maybe is going to say x is equal to -6. Another one will say it's equal to 0. Maybe it's equal to 5. Or other one will say x has no value. How can I find the value of x? I must solve the equation to find the value of x. So that's why we call 4 a constant and we call x a variable. We say that any number is a constant. Why? Because its value is fixed and it will never change. And all of us agree upon the same value. 4, its value is 4. 10, its value is 10. -6, its value is -6. But what about the variable? Variable means that it can change according to the equation itself. Each time I will solve an equation, I will find x with a different value from the other equation. So we call any letter a variable. This variable can be x, z, y, a, b, any letter. What's an equation? An equation is a mathematical statement that shows the two quantities are equal. This means that I must have the two quantities equal to say this is an equation. An equation must contain number 1, an equal sign, number 2, one variable or more. Examples of variable are x, y, z. So, to say that this is an equation, I must have an equal sign and I must have one variable or more. Now let's go and see how can we determine the degree of an equation or an inequality. The degree of an equation or an inequality is determined by the highest power of the unknown. So this means that I'm going to look inside of the equation or the inequality for what are my unknowns and then see which one of those unknowns have the highest power. This will be the degree of my equation. Let's go and have some examples. Now I have 5x plus 2 equals 7. To determine the degree of this equation, first I would like to know where is my unknown. My unknown here is x. What is the power of x? Since there is no power written above x, then x is to the power of 1. Since x is to the power of 1, so my equation is of the first degree. And how many unknowns are there in this equation? I have one unknown, which is x. What about the second one? X squared plus x minus 3 equals 0. What is the degree of this equation? First, what's my unknown? I have x to the power of 2 plus x. Which one of them have the highest power? Of course, x to the power of 2 have the highest power. So, this equation is of the second degree. And how many unknowns do I have? Although I have here x squared and x, but at the end I have the variable x. So this is of one unknown, which is x. Coming to the third one now, 2x plus 3y equals 5. What is the degree of this equation? First, I have x as an unknown and y as another unknown. What is the power of each one of them? Since there is no power written above, so each one of them is to the power of 1. As a result, this equation is of the first degree. But here we have two unknowns, x and y. The last one is 4x minus 7 greater than 5. And here I would like to draw your attention. Greater than, this is the sign of the inequality, which we're going to explain in details in the coming video. Now, what is the degree of this inequality? Again, I must determine my unknown. I have here x as an unknown, and since there is no power above, so x is to the power of 1. So my inequality is of the first degree. And how many unknowns do I have here? I have only one unknown. I want you please all to take a deep breath. Read carefully how can I determine the degree of an equation? And then let's go and answer this question. Here we have x to the power of 3 plus x to the power of 4 plus 2 to the power of 5 equals 0. Which degree is this equation? I know that some of you said that this equation is of the fifth degree, but that's wrong. Why? Because we said that we determine the degree according to the highest power of the unknown. 2 is not an unknown. My unknowns here are x to the power of 3 and x to the power of 4. So, which one have the highest power? X to the power of 4. So this equation is of the fourth degree. Now let's have a look at this equation. X plus 2 is equals to 5. We call this the left-hand side of the equation. Of course, this is the equal sign, and this is the right-hand side of the equation. X here is my variable or my unknown. What is the value of x here? What number? I will add to 2 and I will have a result of 5. It's a very easy question and sure all of you know it. X here is equal to 3. If I made 3 plus 2, I will have the result of 5. The number 3, which satisfies this equation, is called the solution. So, I say that number 3 is the solution of the equation. But when I put number 3 inside the set, this is called the solution set with S.S. What is the solution set? It is the set whose elements satisfy the equation. In other words, the solution set is the set which contains the element which is the right answer for the equation. How can I write the solution set? And then I write the solution inside of a set bracket. We have something else here called the substituting set. What's a substituting set? It is the set that contains the probable values of the unknown. What does this mean? This means that this set contains values that maybe one of them is the right answer for my equation. Let's have an example to illustrate what is the substituting set. Find the solution set of the equation x plus 2 equals 6. If the substitution set is -2, 3, and 4. How can I solve this type of questions? First of all, I should know that I must take each element inside of the substitution set and put it instead of x and see if it is going to give me the correct answer or no. If it is going to give me the correct answer, then this is the solution of the equation. Let's go and see. At x equal -2, the left-hand side of the equation, which is this one, x plus 2, is going to be -2 plus 2, which is equal to 0. And sure, I know that 0 is not equal to 6. So now I know that -2 doesn't belong to my solution set. Or by other words, I can say that -2 is not the correct answer. What about when x is equal to 3? The left-hand side will be equal to 3 plus 2, which is equals to 5. And sure, 5 is not equal to 6. So again, 3 is not the correct solution for my equation. 3 doesn't belong to my solution set. What about 4? When x is equal to 4, the left-hand side is equals to 4 plus 2, which is equal to 6. Yes, now I've got the correct answer. So I know that 4 belongs to my solution set. Don't forget that he asked me to find the solution set. How can I find the solution set? Just take the number which satisfies your equation or the number which got you the correct answer and write it inside the set. So here my solution set is equal to set 4. A very important thing in an equation that it's like a balance. An equation is like a balanced scale because it showed that two quantities are equal. So the right hand side of the balance must be equal to the left hand side of the balance, or otherwise one of them will be heavier than the other. In equations, both of them must be equal. So this means that if here is my scale, if I added 3 apples to the left hand side, I must also to add 3 apples to the right hand side in order to have my scale balanced. And if I took away 3 bananas from the left, I must also to take 3 from the right in order to have my scale balanced. Now let's go and see how to solve an equation. To solve an equation, I want you to ask yourself 3 questions. What is the variable? This is the first question. What operation is performed? And number 3, what is the inverse operation? Let's go now and see the inverse of each operation that we use in mathematics. Here are the 4 operations that we perform in mathematics. Each one of them has an inverse. So the inverse of the addition is subtraction. The inverse of subtraction is addition. Inverse of multiplication is division. And inverse of division is multiplication. Now let's go and solve example number 1. Solve the following equation in Z. X plus 4 equals 12. We said that we have 3 questions that we must ask ourselves. What is the variable? And in this equation my variable is x. What operation is performed? The operation performed here is plus 4. So the operation is addition. What is the inverse operation? The inverse operation here is subtraction because the inverse of addition is subtraction. Why do I ask myself what is the variable? I ask what is the variable because to solve this equation I must to isolate x alone at one side of the equation. I want x to be at one side alone. So what I'm going to do is I am going to move plus 4 to the other side with its inverse operation. Plus 4, its inverse is minus 4. So x is equals to 12 minus 4. X is equals to 8. And here is my answer. Now, he told me that solve the equation in Z. So the first question I should ask myself is, does 8 belongs to set Z? Yes, 8 belongs to set Z. So my solution set here is going to be set 8. You can check all answers by, start by writing the original problem, which is x plus 4 equals 12. Plug in your answer. So here it's 8 plus 4 equals to what? It's equal to 12. So we have got the correct answer. Yes. Let's go and see example number 2 now. Solve x plus 3 equals negative 5, where number A, x belongs to Z, and number B, x belongs to natural numbers or n. So here first, I'm going to solve my equation normally and find the solution. Then I'm going to see that this solution belongs to Z, and next time I'm going to see that this solution belongs to n. Let's start and see. What is my variable here? My variable is x. And we said that we want to isolate x alone at one side of the equation. What is the operation here? I made plus 3, so it is addition. And what is the inverse of addition? It is subtraction. Now we are ready to start solving our equation. X plus 3 equals negative 5. We said that we are going to move plus 3 to the other side with its inverse. So it is now minus 3. X is equals to negative 5 minus 3. So x is equals to negative 8. Here is my solution. And I want to find the solution set once in Z and another time in N. Let's first begin with finding the solution set in Z. So the first question I'm going to ask myself, does negative 8 belongs to Z? Yes, sure. Z contains all negative whole numbers, 0 and all positive whole numbers. So my solution set in A is going to be set negative 8. Now let's go to number B. Does negative 8 belongs to N or natural numbers? Of course not. We said that N only contains 0 and positive whole numbers. What can I write in my solution set now? The solution set in B is equals to phi. And remember, phi is an empty set, meaning that it is a set with no elements at all. Since negative 8 doesn't belong to natural numbers, so my solution set is phi. Let's go now to question number 3. Find the solution set of the equation y minus 7 equals negative 13. If the substitution set is number A, Z, number B, N. So I am going to solve normally and then find does my solution belongs to Z at number A and does my solution belongs to N at number B. Let's begin. Y minus 7 equals negative 13. We said that first we want to have the variable alone at one side. This means that I am going to move the minus 7 to the other side with the inverse. So it will be plus 7. Y is equals to negative 6. And now we are going to see this solution. In number A, does it belong in Z? In number B, does it belong in N? So yes, it belongs in Z. So my solution set in the first option is negative 6. What about number B? In number B, the solution set is phi because negative 6 doesn't belong to the natural numbers. Let's go now to example 4. Solve 6a equal negative 12 where a belongs to Z. This means that the value of a must be found inside of Z. Let's first see where is my variable and what operation was performed. A is my variable and it's 6 times a, so the operation is multiplication. A equal negative 12 divided by 6. A is equals to negative 2. So my solution set is set of negative 2. Example 5. Solve b divided by 2 equals 10, where b belongs to Z. So I know now that my solution must to be found inside of Z. What is the variable here? My variable here is b. What is the operation I performed? We said b divided by 2, so it is division. What is the inverse operation? It will be, of course, multiplication. b over 2 or b divided by 2 is equals to 10. I want b to be alone at one side of the equation, so I am going to move divided by 2 to the other side with the inverse. So b now is going to be equals to 10 times 2. b is equals to 20. Here is my solution. And I said that my solution must be found inside of Z. Does 20 belongs to Z? Yes, of course. So my solution set here is going to be set 20. What we have solved until now is called a one-step equation. Let's go now and see another type which is called a two-steps equation. In a two steps equation, I will have two operations formed in the same equation. How can I deal with this? When solving an equation with two operations, first we begin with addition or subtraction. Second, deal with multiplication or division. Let's have an example now to illustrate how can we solve a two-step equation. If I have here 2x minus 5 equal 13. As you can see here, we have two operations, 2 times x and minus 5. As we just said above, first of all, we're going to move the addition or subtraction, and then I'm going to move the multiplication or division. Minus 5, I'm going to move it to the other side with the inverse of subtraction. As a result, I will have 2x equal to 13 plus 5. 2x is equals to 18. Still, I have one more operation here, 2 times x. I'm going to move 2 to the other side with the inverse of multiplication, which is division. X is equals to 18 divided by 2. X is equals to 9. My solution set here is going to be set 9. Yes, it's so easy. Can you see how easy it is? Just keep in mind that when I have two steps equation, first I move addition or subtraction. Second, I move multiplication, and that's all about it. Let's go and have another example. Solve the following equation. 8x plus 4 equals 12, where x belongs to z. So I know by now that the solution for my equation must be found inside of z. Let's have a look again at the equation itself. 8x plus 4 equals 12. How many operations is there? I have two operations, 8 times x and plus 4. We said that we must first move addition or subtraction. So I'm going to move the plus 4 to the other side with the inverse of addition. 8x is equals to 12 minus 4. 8x is equals to 8. Oh, but remember, I still have one operation here, 8 times x. Moving 8 to the other side with the inverse of multiplication. As a result, I will have x equals to 8 divided by 8. X is equals to 1. So my solution set here is set 1. Sure, you find it easy, right? Just keep in mind the two steps that I should make. Let's go and have one more example. Solve the following equation. 5 over 6x minus 4 equals 11, where x belongs to z. Again, my solution must be found inside of z. And let's have a look on the equation again. 5 over 6x minus 4 equals 11. How many operations is here? I have two operations. 5 over 6 times x and minus 4. As we agreed, which one should we move first? Exactly, we should move first minus 4, moving it to the other side with the inverse of the subtraction, which is addition. 5 over 6x is equals to 11 plus 4. 5 over 6x is equals to 15. Am I done now? No, I'm still having here one operation. So 5 over 6 times x is equals to 15. I will move it to the other side with the inverse of multiplication, which is division. X is equals to 15 divided by 5 over 6. X is equals to 18. So my solution set is equal to set 18. Let's go and see another example. Solve the following equation. X plus 3 equals negative 21 minus 3x, where x belongs to natural number. So my solution must be an element in natural numbers. Have a closer look here at this equation. We said that to solve an equation, I must have the variable alone at one side. If you can see here, I have x on the left hand side and minus 3x on the right hand side. What shall I do? And also I have here plus 3 on the left hand side and negative 21 on the right hand side. It's so easy. We are just going to have x at one side alone. So I am going to move minus 3x to the other side. And when I move to the other side, I am using the inverse of the subtraction, which is addition. And as well, I am going to move plus 3 to the other side. And by moving plus 3 to the other side, I must use the inverse of addition, which is subtraction. I will have now x plus 3x, y plus 3x, because I moved the minus 3x to the other side beside the x, is equals to negative 21 minus 3. What is x plus 3x? X plus 3x is 4x. And what is negative 21 minus 3? It's negative 24. So 4x is equals to negative 24. Am I done here? Of course not. I still have another operation. 4 times x. I will move the 4 to the other side with the inverse of multiplication, which is division. X is equals to negative 24 over 4. X is equals to negative 6. But remember, he told me that x must belongs to natural number. Negative 6 is found inside of natural numbers? Of course not. So as a result, I will have here my solution set as 5. Yes, we are done with today's lesson. Hope you enjoyed today's lesson. Thank you, Prep 1, and have a nice day.